So now I want to take a little bit of time to talk about something called difference quotients. First we want to talk about where they come from, and that's what this video is going to be about, how we come up with this idea of a difference quotient. And then in our next video we'll actually look at computing difference quotients. So the idea is if you have a graph of any old function and we draw the secant line, this is a line passing through 2 points on our graph. We're going to label those 2 points there x, f of x for our first point. And then we're going to go a distance over some other point. That would be an x value, x plus h. H could be positive or negative depending on whether we're moving left or right from the first point. So that would make this next point be x plus h, f of x plus h. Okay, so those are the 2 points on our graph, and what we're going to be looking at is the slope of that line that passes through those 2 points. So what a difference quotient is, it's actually the slope of the secant line. It's actually the slope of the secant line. That's what we're looking at when we talk about a difference quotient. And what that slope of the secant line tells us is the average rate of change of f between those two x values, whatever x and x plus h might happen to be. And that's called a difference quotient. Difference quotients are actually important as we will eventually get into some calculus where we're going to do something with these difference quotients. Right now we're just looking at finding them and being able to compute them. So what does the difference quotient look like? Well, when we write our equation like this, or look at our graph as we labeled it, it's just the slope of the secant line. Remember, the slope of any line is just the difference of the y's over the difference of the x's. So we could say difference of the y's, f of x plus h minus f of x over the difference of the x's, x plus h minus x. And you'll notice in this example, the x's in the bottom cancel out so that we have f of x plus h minus f of x all over h. Okay, and so that's our first difference quotient. There is a second way, and it just depends on how we label the graph. Okay, so as we continue on, here once again I have a graph, and again I can draw in my line passing through the 2 points there. I'm still going to label the first line as x, f of x. The second point though I'm going to label as a, so the point would have coordinates a, f of a. So on the one hand, we're deciding in the first example there with the x plus h that we're going h units away from x. This way we're saying, hey, we just have some second point. And we can still talk about the difference quotient. That would just be the slope of that line, which in this case would be f of x minus f of a over x minus a. This may look a little nicer, but it turns out it's actually harder to simplify difference quotients in this format than it is in the previous format. But we're going to look at them both ways and look at actually computing them for particular functions. And we're going to do that in the next upcoming video.